Okay, so I had somebody ask about the pendulum problem on page 432, number 13. You're given this formula where t is the time in seconds that it takes a pendulum to complete one complete swing. And to find that time, you take 2 pi times the square root of the length of the pendulum in feet divided by g, which is the constant. It's a constant, and it's the acceleration due to gravity. They didn't provide you a picture. So, but if you've ever seen a grandfather clock and you've seen this pendulum swinging, that's kind of what it's talking about. So in part A, they talk about this pendulum in Tokyo, Japan, that this is this huge pendulum in a building there. And the pendulum is measuring 73 feet, 9.75 inches. So the problem on this one, because all you have to do is really substitute the numbers in, but maybe you're not sure what number to substitute in because L has to be in feet. So we need to know how many feet this is. So if we take 9.75 and divide by 12, because there's 12 inches in a foot, we get 0.8125. So L for this problem, L is 73.8125. That's what you want to use for L when you plug in the value. And then G, they tell you, is in 32 feet per second squared. So we're going to have 2 times pi times the square root of 73.8125 and then divided by G, which is 32. So when you do that, we get that the time is about 9.54 seconds. And that's how long it takes to complete one complete swing. So now we're asked, well, what if t equals 20 seconds? How long should the pendulum be? So now when you plug that in, that gets plugged in for t. So we have 20 equals 2 pi times the square root of L over, remember G is still a constant, it's still 32. So now we're trying to solve this radical equation. So to do that, the first thing you're going to do, you have to isolate the radical. So we're going to divide by 2 pi. So we're going to have 20 divided by 2 pi equals the square root of L over 32. And I can reduce that to 10 over pi, but I don't want to use the pi yet on my calculator until I'm ready to solve it because I don't want to round. I just reduced the 20 over 2. Now I'm going to square both sides to undo the square root. So if you square both sides, I'm going to end up with 100 over pi squared equals L over 32. So now I'm going to solve for L by multiplying by 32. So when I multiply 32 times this, I'm going to have 3200 over pi squared equals L. So I can take 3200 divided by pi squared, and I get that L is approximately 324.2, and I believe we are in feet. So that would be the length of the pendulum, which is a really long pendulum. Okay, so hopefully that helps.